Hello, this is Ms. DB, and in this lesson we are going to learn how to find the area of composite figures. And this is Chapter 9, Section 3, and our objectives are to use the area addition postulate, which just says that the area of one piece plus the area of the other piece together will equal the area of the whole thing, to find the area of composite figures, and then we'll also do some estimating of irregular shapes. A composite figure is made up of simple shapes such as triangles, rectangles, trapezoids, and circles. To find the area of a composite figure, you can find the areas of the simple shapes and then use the area addition postulate, add all those areas together, and you'll have the area of your composite figure. For example, in this picture we have this kind of odd-shaped figure. It looks like a half of a circle plus a trapezoid. So we will divide it into those parts. And the area of the half circle is found, so you need to remember your formulas, look them up, write them down, and the project for this chapter would be a really good time to start doing that project. It's to have a formula book. So if you have that started, you can pull that out and look up your area formulas if you need them. So it's a half a circle, so instead of pi r squared, you take half of pi r squared. And remember that that's radius, and this whole diameter is 20, so you have to take half of that too. So 1/2 of pi times 10 squared. 10 squared is 100. Half of that is 50. So it's 50 pi. We'll decide later if we need to round that. We probably will. Now, they found the area of a triangle. I would argue that it would be better to use the area of the trapezoid. So there's more than one way to do these. The area of a trapezoid is found by taking 1/2 b1 plus b2, and I know both of those, times the height, and I know that too. So I would take 1/2 of 20 plus 32 times the height of 14, and I would take this answer and add it to this answer, and I'd be all done. So 20 plus 32 is 52, so I have a half times 52 times 14, so a half of 52 is 26. So 26 times 14 is equal to 364. So I'd have 364 plus 50 pi. And at that point, I would find out what 50 pi times pi was. Where's my pi button? I'm using my calculator here. And it's better to use the pi button on your calculator than it is to use 3.14, because 3.14 has been rounded already. It's really 3.1415, and then there's more digits after that because pi just keeps going and going and going. So use as many digits as you can, and I get, it's just a little over 521 when I add these together, like 521.1 maybe, if it says round to the nearest 10th. But don't use 3.14 for pi unless you have no calculator that has a pi button. Now they did it by finding the triangle and then the rectangle and then the half circle. So they got the area of the triangle was 84, the area of the rectangle was 280. So altogether they also got 521.1. Now this is a crazy looking figure. We've got triangles, trapezoids, things going on all over the place. Possibly oh yes, we have a parallelogram there. So this piece right here is a parallelogram, and we are given the height of that parallelogram. So I would divide this into a parallelogram there and then the triangle down there. Now they maybe did more than that. Let's see. The area of parallelogram is base times height. And we know the base is 8 and the height is 5, so that's just 40. And then we have a triangle, which is 1/2 base times height, so 1/2 5 times 5, or no, 1/2 10 times 5, sorry, is 25. So 40 plus 25 is 65 square feet. So this one actually did not end up being that bad once we divided it into parts. All right, here's a crazy looking figure. but we can find the area of it by dividing it into a rectangle plus a triangle. And our rectangle formula is area equals base times height. That one's easy to remember. And you should also have memorized the formula for a triangle, 1/2 base times height. Now, the rectangle pieces are given as they are. To find the base of this, you'll have to take 75 minus 37.5. And then the height is not given to us, the height of that triangle. So our triangle, we're going to need some more work to find the area of this triangle. We know that 75 minus 37.5, oops, I added 75 minus 37.5 is, oh, that's 37.5. And we'll need to use Pythagorean theorem to find our height. So remember, when you use Pythagorean theorem, if you're looking for one of the legs, you don't add the two amounts that you are given together. You'll have to be subtracting here. All right, so the rectangle part is easy enough to do. That one's 843.75. To do the triangle, we have to find the height first. So 62.5 squared, 65.25 squared is 3906.25, and 37.5 squared is 1406.25. Let me put my h squared here. So then I would subtract, whoops, that's a plus, 1406.25. So h squared is equal to 3906, using my calculator here, minus 1406.25, and that's equal to, conveniently, 2,500. I guess I could have subtracted that faster. The square root of that is 50. So once I take the square root of both sides, I get that the height is 50. So my triangle formula is given by 1/2 37.5 times 50, and that's 937.5. Then I will add my two parts together, and 843.75 plus 937.5 is equal to 1,781.25. They rounded that to 3, but I would leave it like that. Meters squared. Now here's an interesting one. We have a triangle with like a bite cut out of it. In order to this one, it's much easier, almost maybe it's necessary, to find the area of the triangle and subtract the area of the half circle. So the area of a triangle, the base and the height is given to us. We don't have to do any Pythagorean theorem here. It's just 234. Remember that it's a half a circle. And also remember that the radius of this half circle is half of the diameter. So it's 1/2 of pi r squared, and r is 4.5. They forgot to write the squared on here, which makes me wonder if there's another mistake. So I'm going to check their work there. I don't think they squared it. So 4.5 squared is 20.25. Well, maybe they did. And I'm going to divide that by 2. Yep, that's 10.125. So 10.125 times pi is the area of the circle part. So you're going to take the triangle minus the 10.125. So you get, and it's not 10.125, it's 10.125 times pi. So when you multiply that by pi, you get approximately 31.81. So 234 minus 31.81 is about 202.19, 202.2. So you might have to subtract. Sometimes that would make the most sense. In this one, they're asking, make sure you find out what they're asking for. They want the shaded area. So not the trapezoid, but the circle minus the trapezoid. So you find the area of the circle, and then you subtract the area of the trapezoid. And you know how to find both of these. And again, you should be working on your project now, which is your formula book. And you would take area equals, the circle would be pi times 10 squared, because the diameter is 20, so the radius is 10 from here to here. And then you're going to subtract the area of the trapezoid. And a trapezoid area is given by base 1 plus base 2 times the height, and then divide by 2 or multiply by half. One of the bases is 20, one of the bases is 12, the height is 8. So we're given everything we need, and then it's just a matter of plugging it all into your formulas, subtracting to find the area of the shaded region. This problem, I want you to think about it and try to solve it yourself. It's again the shaded region, so out the circle minus the square or the rhombus that's in there. And then you can pause the video and check your work and see if you got it right. So you found the area of the circle. You should have got that was 28.3. Otherwise you could have just wrote 9 pi. Make sure that you use 3 for your radius and not 6. And then the square would be 18 inches. So how did you find that? Well, you know that the hypotenuse of your right triangle is 6. So you need to find this side over here. So you could do several different things. You could say, well, this is a right triangle, so a squared plus a squared equals 6 squared. That's 2a squared equals 36. So a squared equals 18, and then you take the square root of both sides. That's one way to do it. You could have also used trig on this. You could have said, well, this is a 45-degree triangle. So I'm going to use the fact that a 45-45 right triangle will be the hypotenuse. If you know the leg times the square root of 2 equals 6, so you could take 6 divided by the square root of 2. I'm doing that on my calculator right now. And the decimal version of that is 4.2426. So there's more than one way to find a, but you had to find that before you would be able to then multiply a times a and get 18. And then you subtract the two amounts and you should have got 10.3 inches squared for the shaded region. This is just another application. In this one we have a square that's 3 by 3. That's 9. That one's easy to do. And then we also have this circle that it's a heart shape, but if you put these two bumps from the circle together, you would get one circle. So it says there's an order for 65 pieces of fabric to be this heart shape. Each piece is to be dyed red. To dye 6 inches squared of fabric, 2 ounces of dye is needed. How much dye is needed for the entire order? So the first thing you would have to do is figure out what is the area of this shape. So the area of this shape ends up being 16.1 inches squared. And they said that 6 inches squared, oh, and then there's 65 of those. So we have approximately 1,044.5 inches squared of fabric. And every 6 ounces needs, I have to look back at the question to see what they said. Every 6 inches squared needs 2 ounces of dye. So you would divide this number by 6 and then multiply it by 2. And you get 348 ounces of dye. Okay, irregular shapes can be done 2 ways. If you got this crazy kind of pond and you have to estimate what the area of it is, you could either divide it into regular shaped polygons that you know how to find the area of, and then find the area of each piece. So here's an example. We got this crazy looking thing here. And I'm going to divide this into triangles. Let's see. Here's a trapezoid. Here's a rectangle. So I've got this triangle right here I'm going to call triangle A. And I would find that by taking 1/2 base times height. And the base here is 1, 2, and the height is 1. So 1/2, 2 times 1 is just 1. Okay, there's my triangle A. Then I'm going to do triangle B and E. They look kind of the same. I'm going to use these two. And both of them have a base of 1 and a height of 1. See, base of 1, height of 1. So they're both equal to 0.5. There's two of those. Rectangle C, I'll call this rectangle C, has a base of, it's just base times height. The base can be 2. Here's your base of 2 and a height of 1. So that's just an area of 2. And then I've got a trapezoid left. I'll call that trapezoid D. And my trapezoid is found by taking 1/2 base 1 plus base 2 times the height. So one of the bases is 2, one of the bases is 1. That's 3. 3 times 1 is 3. Divide that by 2, you got about 1.5. So when I add up all of these pieces, I get that the area is about 5.5. So you could do this. If this was a real lake, you could draw a grid on top of it. You could divide it into polygons that you know how to find the area of, add up all of the pieces using the area addition postulate, and you get your approximate figure. Another way to do this is to, this is the same thing. They break it up into those pieces and they find the area of those different size pieces. This one they have kind of a half circle. So they've got a triangle up there in the top that's base times height would be 2 times 2 divided by 2 is 2. There's a half circle there. And then there's a rectangle. And they added up all those pieces. Okay, so I don't want to do that for this one. Because it's crazy. But here's how you would do it if you wanted to divide it into all of these polygon-shaped pieces. And they came up with some formulas, and I don't even know how they did it. Here's what I would do for something that crazy. I would just count the full squares. So I'd put the grid on top, and I'd say, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 20. There's like 24 whole squares. And then I would count all the half ones. All the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 half of them. Maybe 15 there. So that's about 31. And I would say maybe I'd put like these together to make one more. You know, the ones that I didn't count at all. But then some of my whole squares or my half squares maybe were a little bit short. But I would maybe round that to 32. So you can pick when they're irregular like this. You can decide whether you want to divide it into polygons or whether you're just going to count squares. I would count squares for this one. I would say there's a whole 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. I've got 33 holes. And then I'm going to count the pieces. 1, 2, I'll use a different color. I'm going to count my halves. So 1, 2, 3, 4. I'm going to count 5, 6, 7, 8, 9. And then I think I'll add an extra one for all those pieces I cut off. So I have 9 halves, so that's 4 point, and I'm going to call that 10. So I'm going to call that 5. So that would be 38. So I counted like 10 half squares, And then I added one more for like all these little pieces that I didn't count at all. There's a lot of those. So I've got approximately an area of 38, which is what they got to. They counted 33 full. Okay, so you can decide when you have those kind of crazy looking irregular ones which way you want to do it. And that's it. Good luck. Let me know if you have any questions. Have a wonderful day.